So today we're going to dig into a really fascinating proposal called BitBallot. It's a completely new take on electronic voting. We're going to break down how it's designed to work and, maybe even more importantly, look at the fundamental technology choices behind it. Choices that could really change how we think about trust in any digital system. Okay, so let's just get right to the heart of the problem. Here's the big question, right? Is it even possible to build a voting system that can do it all? Something that can scale up for an entire country, that keeps every single vote perfectly secret, but is also completely open for anyone and everyone to check and verify? For decades, this has been the absolute holy grail of digital democracy.
And this challenge is so incredibly difficult that experts literally just call it the voting problem. It's this constant, tricky balancing act between a few critical requirements that honestly seem to want to pull in completely opposite directions.
See, the issue is you're almost always forced into a trade-off. You've got to have incredible speed to handle millions of votes at once. You need total absolute secrecy, just like a physical locked ballot box. You also need a system that can resist people being threatened or paid off. And on top of all that, it has to be completely transparent so the public can audit everything. Trying to get all four of these things to work together perfectly, well, that's been the major roadblock for years. All right, so that's the problem, and that's where BitBallot steps onto the scene. The core idea here is to solve this whole puzzle by keeping things surprisingly simple. Instead of building on complex, secondary layers, the plan is to build everything directly on the main network foundation, what's called a Layer 1 block DAG. You can think of it like building a skyscraper directly on solid bedrock. It's all about maximum security and verifiability right from the ground up. So how does this thing actually work under the hood? Let's peel back the layers and take a look inside the system, starting with a really clever hardware design. The whole design philosophy is fascinating. It's built around what they call economic optimization, not building expensive custom machines. For example, the zero-knowledge processing, which is just a fancy way to prove something is true without revealing the secret itself, is capped at just 10 transactions to keep things super fast. Your secret key, it stays on a separate NFC card, so it never even touches the main terminal. They even physically seal off the USB ports. It's all about being low-cost but high security. And get this, here's what that philosophy leads to. A whole voting terminal can be put together using a second-hand mini PC for about 10,000 Japanese yen. That's less than $100. This massive cost reduction is what could make a secure nationwide rollout actually feasible. Okay, so the hardware is cheap and it's secure. Awesome. But what about the really tricky part? How does the system protect you, the actual voter, from being forced to vote a certain way? This is where the cryptography gets really, really clever. Let's just walk through what happens when you vote. First, you tap your card and enter your PIN to authenticate. You select your candidate on the screen. Then, the system generates your one true vote, but it also generates up to 9 totally plausible dummy votes. Now here's the magic. All 10 of those transactions are sent to the network. If someone is standing over your shoulder and demands proof of how you voted, you can just print a receipt for any one of the dummy votes. They're happy, they leave you alone, and your real vote stays completely secret. And the research paper on this is very clear. It states that it is, and I'm quoting here, mathematically impossible for any external party to distinguish the true vote from the dummy votes. This is the whole ballgame. It fundamentally shatters the business model for coercion and for vote buying because there is literally no way to prove how someone actually voted. And there's another safety net built in too. Let's say you are forced to cast a vote against your will. Well, BitBallot lets you just vote again later. The system is designed so that only your very last vote counts, which automatically makes any previous vote you cast totally invalid. It's a neat little failsafe. Now, a system this ambitious depends completely on what it's built on. So let's zoom way out for a minute and look at the engine that would make all this run. This critical, fundamental choice between two different technologies called proof of work and proof of stake. Just a quick refresher so we're all on the same page here. A consensus mechanism is basically the rule book. It's the method a decentralized network uses to all agree on what's true. It's how thousands of computers all over the world can maintain one single shared source of truth without any central boss calling the shots. And this is where we get to the great debate, the core philosophical difference. On one side, you have proof of work, which is the engine behind Bitcoin and the one proposed for BitBallot. Its security is based on physical power, real-world energy, real-world hardware. You can think of it like a digital commodity, like gold. On the other side, you have proof of stake. Its security is based on abstract power,
basically how much of the network's currency you already own. This works a lot more like digital equity, like owning shares in a company.
And this brings us to a potential long-term risk in proof-of-stake systems. You see, in almost any economy, wealth tends to concentrate over time. It follows something called a power law. This means that eventually a very small group of holders can end up owning the vast majority of the assets. Now, in a proof-of-stake system, that wealth translates directly into control over the network's consensus.
And that right there is the crucial difference with proof of work. Simply owning a ton of the currency gives you exactly zero control over the network. To have influence, you have to constantly perform real-world, physical work by expending energy. Your power in the system comes from what you do, not from what you own.
So you can see, this choice of engine, it isn't just some technical detail for developers to argue about. It's really about what kind of trust we want to engineer into the foundations of our digital future. So let's bring it all back to voting. Why does this engine matter so much for a system like BitBallot? Well, a proof-of-work foundation is chosen because it's fundamentally designed to resist censorship. The entire goal is to build a trustless system, one where you don't have to trust anyone. It's about making sure a small group of wealthy stakeholders can't take control of the digital voting booth, and it ensures that absolutely anyone can check the results without needing to ask for permission.
And that really leaves us with this one giant question. These aren't just technical decisions about lines of code. They are deeply social and even political choices. So as we design the infrastructure for everything from our voting systems to our financial markets, the fundamental question we have to answer is this. As we build our digital future, who or what should hold the power?